All right, so part 3 was the section about correlation and regression. This is where we started doing some of our first, like, let's look at two variables versus each other, right? So in this case, we're looking at a relationship between two quantitative variables. So hugely important because this is what a lot of you guys are going to be doing in your project. And it's our first, at this point, informal look at an inferential technique. We didn't actually do the inference, but I can pull that in now for the test. So for the final exam. So first off, our display when we're looking at quantitative versus quantitative was a scatter plot where we have our x versus our y, right? So that was one thing we had going on. We had a descriptive, which was our correlation coefficient, right? Our little r. Normally that'll just be popped out by an actual computer program, but if we want to calculate it, it is related to our r squared. So remember, we can go ahead, if there's an r squared given, we can square root that, making sure we enter this as a decimal. And that we make sure to put back on whatever the sign of our slope was. That way we have the direction of our relationship. So look at the slope of your regression line. Now here's the new thing, is when our correlation, if you were to do something in StatCrunch, you can now get a p-value. So we really need to be able to understand what our null and alternative hypotheses are when we're talking about a correlation. So just like with our chi-squared tests and pretty much everything, our null is that there is no relationship. And technically, correlation talks about no linear relationship, no correlation, relationship between my x and y, right? My two variables. So our alternative is, there is. So that correlation, which you're going to look at, whatever your correlation is, you have a p-value given with that. And the p-value tells you whether or not there is a linear relationship between your x and y variables at a certain significance level, right? So that's our correlation, correlation coefficient. So this is where we had also maybe a sentence that we might have to have in here, interpretation. There is and I'll just make one up, strong negative linear relationship between x and y. And remember, what we're inputting here is the strength, the direction, and then whatever our variables are. So there's a strong negative linear relationship between crime rate and housing price, right? So the higher the crime rate, the lower the housing price. Makes sense. So know that interpretation. We also had our linear regression itself. This is when we had our little line. So we'll have a given line. You guys don't have to do the work here. It'll just be there with some, I'll just make one up. Right, something like that. And then think about what we could do with our linear regression. We could interpret the slope. And when we interpreted slope, this was for every 1 increase in x, our y increases by 5.2. And we had to make sure we have our units in there. We could make predictions. So if the crime rate for a particular state is this amount, we could actually go ahead and predict what the housing price would be in that state. And then we can calculate residuals, which is something you definitely want to have on your note card, right? E is equal to y minus y hat. You find a residual by taking the actual, in this case, my example that I've been using, the actual home price in a state, and you subtract off what you predicted the home price to be based on the crime rate. Other pieces we had in this section, we had our r squared, which gave us our, it's our coefficient of determination. It was what told us basically the percent of variability that could be explained, remember? So two things you might want to have down. One, the calculation. You can take your correlation, square it, and multiply by 100%. It tells us about the predictive power. Well, remember, closer to 100 is better. So something close to 100 means we described almost all of the variability. So we could almost tell you why housing price is what it is based on all this stuff if we had that. So that's our R squared. And it had that interpretation too, which you don't need to memorize, but you should know because I could talk to you about, I could reference it that way, which is the percent of variation explained. I'm trying to remember if there was anything else, but I think it's just scatter plot, correlation, linear regression, and then we talked about predictive power. We had some other definitions at the very end, like extrapolation, influential points, outliers, leverage. So there were other things that we talked about here. Again, most of it in terms of definitions. I'm not going to be looking for that as much on the final exam. That's nitty. That's like nitpicky. I'm going to be thinking more big picture. So I might give you a graph or something and ask you what's going on, or can I make a prediction outside this range? And I'm not expecting you to pull out the word extrapolation, but I am expecting you to look and say, oh, well, we're only looking at, crime rates up to this value. So anything past that, we can't really be sure that it keeps going in a line. So more common sense again. But the rest of this, definitely make sure you know how to do all of this stuff related to linear regression. Everything related to correlation coefficient is huge as well. Yeah, that's about it. That's part 3.